Okay, 7:59 employee free time. We are given a list schedule of employees, which represents each employee. Each employee has a list. Return a file or representing common positive length free time for all employees. So 3, 4. This is excluding. Schedule 0, 0. What the hell? So he works. That's the worst explanation. But okay. Oh shit, 50, that's not looking good. Common, positive, and free time for all employees in sorted order. Well, my first idea was that I guess we just run the intervals, making all of these intervals, and that's what, 2500. I don't see why that 50 is very suspicious. It's 50 times 50. But I'm not sure why my method wouldn't work, to be honest. 5, 6 excluding 6, and then I don't see why that wouldn't work, to be honest. We just do a sweep line over all intervals, and then each time an interval starts, we check if there is currently 0 intervals open, and I guess that's it. There is not much else to it, to be honest. Log of that is 10, so we are looking at around 20 something thousand. They could have made it at least 100 or even 1000. That would be a million intervals. You can still do nlog, and that is very suspicious. Whatever. Okay, so let's make events schedule in schedule or auto interval in schedule events push back for int sindex schedule size sindex plus plus and in schedule sindex we go through intervals, right? And now will be pushback well opening of the interval, which is interval start, and then that it's opening, and then it's s index push back, and then it's end, and that is this guy. Now what do I want to do? Do I want to close before they start? Probably. So starts are marked 1 and 0, so that when I have like intervals 2 and 5, and then 5 and 6, when I sort them, I first process that 5 finished, because 5 really did finish before this one finished before 5, and only then 5 starts. My days. Okay, so then we just sort the events. So that's Python sequencing. Okay, and then so what I need to keep is a set of employees. I mean, there is only 50 of them, so in work, wait, that's in work count is 0, and then we have int people schedule size, this many people, right? And then we have in work of people, right? That's a boolean vector marking if person is at work or not. Actually, it's marking the number of open intervals for them. They should not be intersecting. We go for events, so auto events, and then we got that cycle pause is event 0, marker, or we can call it type, is event 1, and then index, so that's person index is event 2. Now if type is 1, so we are inside a opening event, right? So what we need is vector interval answer, and then we need last, I don't know, last pos, let's call it, right? And finally what we do, well, if we encounter a closing event, what do we do? Well, if in work, we can just subtract it, so last pos is position first of all, then in work person index minus minus, if in work person index is 0, then in work count minus minus, else if we have type 1, then if in work count is 0, so there is no one at work yet, then ans push back last and last pos over -1, so that we don't trigger, because nobody is at work when we process the opening of a first interval. So last pos to current pos should work, since if it's a struct we can initialize it by naming the parameters in the order which they are declared. It's a class, so that might not work. Okay, so let's do it like that. Interval, great. And now in work person index plus plus, if in work person index is 1, so he came to work, then we do in work count plus plus, and we return answer, and that should be it. Boom. And now let's see if I'm mistaken. 94, 94. Also I exclude the empty intervals. And pos minus last pos over 0. Boom. Let's see. Okay, that was tricky constraints. That could fool someone. Meh, okay. Editorial is not faster than number of intervals, so log n, because you need to do sorting. So let's write the editorial quickly. Sleep line. Let's order all intervals. let's sweep through the intervals and maintain the number of people in work at each start/end of an interval. We do not have to keep it inside. Keep it at other times, since the answer only changes at the starts. The answer does not change. No, the number does not change at other points in time. If an interval starts and nobody is at work, we add a new interval with from the time last person left the work until now, with some constraints. If it's not the first interval opening and the created interval would not be empty. Okay, approach. Imagine the intervals along the x-axis. We only, as already mentioned, we only care about the starts and ends of intervals, since the number of people at work in the times between are the same. Therefore, we create a list of all intervals, list of events, position, type, and person index. For each interval we create events start, and person index, whatever, and start, interval, and interval, start, and index, where index is the index of the current person, currently processed person. We sort the list of events by position, and in case of ties and events have a higher priority than start events, since the intervals are half open. We want to if we have intervals to 5 and 5, 7, we want to close the first one before opening the this second one. Now we keep intervals for each employee, the number of employees at the work currently, and position of previous event. When we encounter a end event, when processing a event, we store its events. If it processing a end event, if we process a end event, we remove, we decrease, keep count. I mean, let's see, I want to check this. I don't need this, and then I just do in work, and if I don't care, let's run it. In work count, pos minus last pos. That works too. I mean, probably a person cannot be okay. Person cannot be twice. So now we keep count of. Now we keep count of employees at work currently and position of when processing end event. We decrease the number of people at work, and when processing a new event, which processing a start event which is not the first event, and pos minus last pos is 0, i.e. it does not create an empty interval, start event which is not the first event, and there is nobody at work when this person comes in. We create a new interval in which all workers have free time. Last pos O of n log n, where n is the total number of employees, no, total number of intervals for all employees combined. On, since we store 2n events. post, and goodbye. I'm going to learn runtime environments and global analysis of data flow in whatever programs for compilers class. Goodbye.